All right, so forces at angles, we're going to be drawing free body diagrams that help us understand the problem and writing our net force equations for each problem and solving the questions asked. We have a 60 kilogram lawnmower that's being pushed downwards and to the right. We're going to take that 100 Newton push and break it into the rightward component and the downward component. So 45-degree angle, so the horizontal will be 100 cosine 45. That 45 degrees goes in that bottom right corner of the triangle. 100 sine 45 for the downward portion of the push. In the x direction, the horizontal, we simply have 100 cosine 45, so that will be equal to mass times acceleration. In the vertical, it's balanced, so we'll have 100 sine 45 plus mg, two downward forces, is equal to the upward force of force normal. So if we take that bottom equation and we go ahead and solve for 100 sine 45, we get 70.711 plus mg of 600 is equal to force normal. And then the force normal, adding that together, would be 670.711 for the force normal. The force normal is the only force going up, so it is equal to the total downward force. So both answers are going to be 670.711. I didn't complete my free body diagram because I was able to solve the questions without it, but it would be a good idea to say to the right is 100 cosine 45. Downward, in addition to mg, is 100 sine 45. Upward is force normal. Number two, we've got a 60 kilogram wood carving of a gazelle. So we know the mass times gravity, the weight is 600. We've got a push down and to the right of 5 newtons at a 60-degree angle. So 5 cosine 60 is the rightward component of that. And then the downward component would be 5 sine 60 because it's on the opposite side. What's the normal force? Just like what we did before, the vertical forces, we've got the mg plus 5 sine 60 is equal to force normal. And in the horizontal, we've got 5 cosine 60 is equal to mass times acceleration. I'm kind of using the picture on the right and the free body diagram box on the left in conjunction together to utilize as free body diagrams at this point. Let's take the second equation first, and we can say 5 sine 60 is equal to 4.33 plus mg is force normal. So 604.33 is force normal. That takes care of the first question, assuming the gazelle starts from rest, so V naught would be 0. How long will it take Ms. Burns to move 3 meters? So you're looking for time. You know V naught is 0. You know delta x is 3. We need one more known variable in order to solve a kinematics equation. We know that acceleration is an overlap between kinematics and forces, so we probably need to solve for acceleration using that top summation of forces formula there, the net force equation. 5 cosine 60, when I put that in my calculator, I get 2.5. And that's equal to mass of 60 times A, so 2.5 divided by 60. I get 0.042 is my acceleration. Now that I have that, I can do a little bit of kinematics, and I can say that delta x is equal to v naught t plus 1/2 at squared. Delta x being 3 meters. V naught t is 0, so it goes away. And then I've got 1/2 a times t squared. 1/2 of a, 0.042 times t squared. So let's go ahead and take the 1/2 and multiply by 0.042. And then that value, we'll do 3 divided by that value. And that'll be equal to t squared. Then we'll simply square root that value. And I think I get for t squared 142.857. Square rooted, I got 11.92 seconds for time. And again, if you get something a little bit different, it's depending on how many decimal places you're carrying and that sort of thing. So it makes a difference in the value, but as long as the functions are all correct, we're going to be okay. So time again is 11.92. And then if we go on to number 3, suppose Mrs. Burns places the gazelle from the previous problem. So from the previous problem, we still have a mass of 60 into that elevator so she can move it into her classroom. Once in the elevator, she stops pushing on it, so there's no more horizontal forces. What's the new normal force on the gazelle as it's accelerating upwards? If it's accelerating upwards, we know force normal is larger than mg. So we're going to say force normal minus mg is equal to mass times acceleration. So we got normal minus 600 is equal to 60 times 3. Because force normal is bigger, it's accelerating upwards, so we use it first. So force normal minus 600 is equal to 60 times 3, so force normal should get us 780 newtons. Thank you so much. So 60 times 3 is 180. Add the 600 to the other side, we get 780 newtons. All right, to number 4. 200 Newton crate, that is the force of gravity or the weight, not the mass. Gazelle Toys is resting on the floor. If you pull on the crate as shown, what is the normal force? And then some kinematics behind it. So let's go ahead and show what we've got. 50 cosine 60 to the right, 50 sine 60 up. I'm going to have to make that correction. It's like I just inadvertently wrote cosine twice. But we've got 200 newtons down, 50 cosine 60 to the right, 50 sine 60 going up, plus force normal up. Net force equations in the vertical force normal plus 50 sine 60 is equal to the 200 Newton weight downwards, mg. So force normal, let's go ahead and resolve that. 50 sine 60, I get is 43.301. And mg is 200. Subtract the 43.301 to the other side. Do a little mental math at 156.699. That solves for my force normal. How fast will the crate be moving after 4 seconds? It's going to start at 0. We're looking for the final velocity. Time is 4 seconds. We need that third known variable to do our kinematics, so we're going to use that force net force equation, the x. 50 sine 60 is equal to mass times acceleration. 50 sine 60 is equal to 20 times a. I put 50 cosine 60, my apologies. 50 cosine 60 is equal to 20 times a. Get 50 cosine 60 from my calculator, divide by 20 to the other side, and I'm going to get 1.25 as my acceleration. Now that I have initial velocity at 0, final velocity is what I'm looking for, time is 4, acceleration will be calculated at 1.25 meters per second squared. I'm going to use the Votat equation. V is equal to V naught plus A times T. V is equal to V naught, but V naught is 0, so V is equal to basically A times T. A being 1.25, T being 4, and that gets me a final velocity of 5 meters per second. All right, number 5. A 60-kilogram gazelle slides with a constant speed. I've underlined constant speed because constant speed means balanced forces. So I've got 60 kilograms, 600 newtons down. It's being pushed down with a force of 5 sine 60. So my force normal up is going to balance both of those two downward forces down. What's the normal force? What's the force of friction? Force of friction will be balanced with the rightward push of 5 cosine 60 because it's constant speed. We're going to calculate force normal. We're going to calculate force of friction. We're going to start with our net force equations once we get all of our forces listed out. In the x direction, I have 5 cosine 60 is equal to the force of friction. They are balanced because it's constant velocity. You can subtract force of friction and set it equal to ma, and a is 0. It's the same thing. It's going to work out the same way. Vertically, they're balanced, so my force normal up is equal to 5 sine 60 plus mg. I'm going to take the second equation because I can go ahead and solve for force normal. 5 sine 60 is 4.33 plus mg of 600, so force normal is 604.33. Using the first equation, let's go ahead and solve for force of friction. 5 cosine 60 is equal to force of friction. Put in 5 cosine 60 into my calculator, I got 2.5. Once we get that force of friction listed out, the next thing it asks for is the coefficient of friction. Remember, the coefficient of friction shows up in the friction equation. Force of friction is fun. Friction is coefficient times force normal. Well, force of friction is coefficient times force normal. If we divide force normal to the other side, we get the force of friction over force normal is the coefficient. Plug in the values we've already calculated. Force of friction is 2.5. Force normal is 604.33 is equal to coefficient. When we do the math, 0.004 is our coefficient. All right, number 6, a crate of gazelles which has a weight of 400 newtons, so mg is 400, mass is 40, is resting on the floor. So vertically the forces are balanced. Horizontally the forces are balanced, but I think we're about to give it a push. So the coefficient of static friction is 0.5. The coefficient of kinetic friction is 0.35. I'm going to write those just so I don't have to look them up again. What's the maximum force that the static friction can provide? Maximum static is going to be calculated from force normal times the coefficient of static friction. Remember, we don't know that static friction is actually giving us their max because static friction is just trying to maintain equilibrium, balance forces while you're not moving. Once you push beyond its maximum value, it's in motion, you throw static away, and you calculate kinetic friction, which we're going to do in a second. Static friction coefficient times normal, 0.5 times 400, gives us a maximum value of 200 newtons. The question goes on to say if you push with a horizontal force 100 Newton greater than the answer for A, so to the right, we're going to push with 300. If we push with 300, we've certainly overcome the static friction at 200 because we're pushing with greater than 200. So now that we've overcome static, we have to calculate kinetic. Kinetic friction is coefficient times force normal, 0.35 times 400. I put this into a calculator and I got 140 newtons. So to the left of my free body diagram, I'm going to throw a 140 to the left. So in the y, force normal is balanced with force of gravity, but in the x, force applied minus force of friction is mass times acceleration. I know I have an acceleration, so I'm going to go ahead and do the net force is equal to ma. The net force is 300 minus 140, the values that we've gotten, is equal to mass times acceleration. So 300 minus 140 is 160, is equal to 40 times a, divide both sides by 40. I get 4 is my acceleration. I'm going to assume the initial velocity was 0. I'm looking for the final velocity. The time is 5 seconds. So I've got 3 knowns, 1 unknown. Looks like VOTAT is the equation of choice, the kinematics equation of choice. V is equal to, well, V naught is 0, so it just leaves me with A times T, 4 times 5. Final velocity is 20 meters per second. Final question. When you go to college and you need to move a box of books about gazelles into your dorm room, to do so, you attach a rope to the box and pull it with a force of 100 newtons. It's going to make you very, very popular with your RA and your neighbors. At an angle of 30 degrees. The box of books has a mass of 20, so let's throw a 20 down there in the box in the free body diagram and tell on the right side, let's break the 100 Newton force that's going up and to the right. 100 cosine 30 or 86.603 is our horizontal component of the pull. 100 sine 30 or 50 is the vertical component of our pull. So if our mass is 20, our mg is 200. To the right, we have 100 cosine 30, otherwise known as 86.603. Vertically, we've got 100 sine 30, and whatever force normal balances the forces in the vertical. And then there's a force of friction going to the left. Our net force equations in the x, 100 cosine 30 minus the force of friction is mass times acceleration. They're not balanced. Vertically, they are balanced. The box of books is not going to jet off the floor and skyrocket into space or through the roof. So force normal plus 100 sine 30. Force normal plus 100 sine 30 is equal to mg. Using the second equation, I can say force normal is 50, which is 100 sine 30, is equal to 200 mg. Subtract 50 from both sides, I get a force normal of 150. Now that I have force normal, I can certainly get the force of friction because force of friction is coefficient times force normal. They gave us a coefficient, did they not? Looks like it's 0.5. So 0.5 times 150 will be how we calculate the force of friction. 75 newtons. It wants to know what the net force is. Well, vertically, there is no net force. The forces are balanced, so it must be talking about the net forces in the x direction. So the net force is 100 cosine 30 minus the force of friction. That's 86.603 minus 75, which gets us 11.603. Our net force is 11.603. What is the acceleration of the box? Well, the net force is equal to mass times acceleration. So let's just take the work we just did and set it equal to mass times acceleration. So let's just throw an equals ma in there. Now that we know what the left side is equal to, we can set it equal to mass times acceleration, divide the mass to the other side, and then we have the acceleration. Mass is 20, so just divide 11.603 divided by 20, and when you do, I get 0.580 meters per second square as my acceleration.